The Institute for Integrated Energy Systems is a multidisciplinary research center at the University of Victoria. Our membership right now consists of approximately 22 faculty members and postdoc researchers. We have approximately 70 to 75 graduate students at any one time. And every once in a while we have some undergraduate students who are working for co-op terms in our laboratories. The Institute was founded as a research group in 1989, and at the time the focus was really on hydrogen economy questions and the development of technologies to develop a hydrogen economy. Over the years we've changed our scope. It's broadened tremendously. The mission though has stayed the same, so the mission of the Institute from the beginning has always been about charting feasible pathways to sustainable energy systems.
So my work focuses on energy systems integration, which is the process of coordinating the planning and operation of our energy system over a variety of spatial temporal scales and infrastructure systems. The main idea behind energy systems integration is really to take a broad perspective of our energy system instead of focusing on specific subsectors like the electricity system or the building system. By taking such a broad perspective, we're really looking to leverage opportunities that exist at the intersection between these different subsectors to take a perspective that can decarbonize the energy system as a whole.
One of the areas I work on is cities. Cities are growing worldwide. There's more than half the global population lives in cities. And by the middle of this century, we're expecting another 2 billion people to live in cities. Cities require huge amounts of energy just both to construct them and also for people to live in them. And so many of the energy challenges going forward are all about cities. So over the next few decades, the built environment is going to grow dramatically in cities. Some of the work I do is I study what's called urban metabolism. That's the energy and materials going in and out of cities. So it's energy from electricity, gasoline, natural gas, and also renewable forms of energy. It's also materials such as water and food and waste coming out that I study.
West Coast Wave Initiative, or WCWI, is a comprehensive wave-to-wire modeling study for wave energy technology. So the idea is to use computing power to simulate the operations of wave energy converters in BC wave conditions and try and get some detailed pictures of the energy that those devices would put out. And once we have that detailed picture, we're able to feed those numbers into some work that looks at how communities on the BC coast could utilize that power. So the wave energy research that we're looking at is important because it's a national priority to get remote communities that aren't on the main electrical grid off of diesel generation. And if you look at Canada, if you take a national look, the highest concentration of remote communities is actually on the BC coast. And unfortunately, mature renewable energy technologies that could replace diesel, like wind turbines or solar panels, which have a lower cost of energy, and you would think would be suitable replacements, they don't work as well in our climate. In fact, the predominant renewable energy option on the BC coast is moving saltwater.
Integrated energy systems analysis is essentially an approach that allows us to look into a holistic manner at all the links in the energy chain from the supply of energy to its end use. And it's an approach that's very fruitful in determining what are the optimal pathways for decarbonizing our energy system and for putting components together that are best suited to achieve our goals of sustainability.
Being a part of ISVIC for me, it's been all about the connections. We work very closely within all the students that are part of ISVIC and within the professor, like faculty, staff. We all work together, which has been very helpful for integrating myself here at UVic. But it's also, I think, connections outside of the university. ISVIC is well known, and it helps you when you're at conference or public events. It helps you kind of being accepted, it gives you some credential.
The future of ISVIC will be to expand its research in terms of understanding society and the impacts and constraints of society's values on our energy system. We need to transform a lot of infrastructure that has been built to last a long time, and the footprint of this infrastructure is significant.